Hi, everybody. So, I wanted to start off with a simple lesson based in algebra. So, today we'll be talking about finding the slope of a linear equation. So, we'll start with, in general, right, linear equations, which follow this format we call y equals mx plus b. So, you might be wondering, what is that? What does that mean? Blah, 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 right? We'll talk about all of that. So the first essential part of this equation is the m. So m, when we refer to m, we refer to the slope. Ooh, the slope. And what is slope? We'll talk about that in 1 second. Hold your horses. And then B, the B, we talk about what does B represent? So B represents the y-intercept. So y-intercept. And we'll write it as y-int for short for my writing purposes. So back to that slope thing. What is slope? So slope is defined as what we call rise over run. So the best way sometimes to show examples in math is to just draw it out and understand it visually. So a linear equation, right? We say linear has the word line in it, right? So it's always going to be a straight line, whether that's vertical, horizontal, diagonal. It always has a consistent slope. Now, another word for slope is rate of change, right? So how fast is this line going? How fast is this line moving in the positive or negative direction? So let's do an example here. I'll make some really basic assumptions about this line. Ooh, let's put this right here on the coordinate 2. Now, always remember that my graphs are never beautiful or accurate because I hand draw them, so we'll do our best here. So the point I'm going to show you here is the rate of change of this line. So how we find slope is how many markings in this graph did we go up, and then how many did we go over. So they call it rise over run. So rise meaning how many did we go up for each block, and then run meaning how many do we go over in the horizontal direction. So we can easily calculate this. For example, here I went, let me get a new color. So I went from here, I went up 1 to 2 on my graph, or I guess 3 on my graph, right? And then I went from here over 1, and I ended up at this point. So I went up 1 over 1. So my slope is simply 1. Nice and easy, right? And in a linear equation, I know that my graph isn't perfect and doesn't show this, but for easy, it's okay. But in theory, this should be consistent throughout the entire line. So that means for every point, I should go up 1 and over 1 and up 1 and over 1 forever in both directions. So that is the basic of what slope is. And the little equation that you may see often written about slope looks like this. You y2 minus y1 over x2 minus x1. And I'll give you an explanation briefly of what that exactly means. Let me just clean this up. So y2 minus y1. So let's use the 2 points here I created as an example. So if I wanted to find the slope of this line and I had these 2 points, right? These 2 points in a coordinate plane look like they are at 1, comma 3. And this point over here looks like my lower point. Looks like it's at about 0, 2, right? So these are my 2 points. Now, the important part of this equation is that it doesn't matter which one you designate to be 1 or 2 in your coordinates. Like whether or not I choose 0, 2 to be my y1 or my y2, doesn't matter. And we will prove that in 1 second. So for this purpose, I'm going to use 0, 2 as my first point and 1, 3 as my second point. Okay. So that being said, my y2, right? My y2. Okay, so I have to go to point 2 and find the y coordinate, which is 3. So this is going to be x2, and then 3 is going to be y2. So y2 is 3. And same thing over here, right? I'm going to have x1 and y1. So I'm going to have 3 minus my y1, which is 2. And on the bottom, I'll have x2, which I have 1. And then x1, which I have marked as 0. So now we can prove with this equation that 3 minus 2 gives us 1. 1 minus 0 gives us 1. And we can again conclude that our slope is 1, just like we calculated with the rise over run by counting. This is just doing it with an equation, which can be helpful if we have a more complex slope. I wanted to prove that it doesn't matter which one we mark as point 1 or point 2. So just to verify, I'm going to switch my coordinates now. So instead of my 1 is going to be 2, and my 2 is going to be 1. Just in case you didn't know which one to pick as 1 and which one to pick as 2, let's prove it. So our new y2 is 2, and our new y1, so it's going to become the opposite, right? So 2 minus 3 and 0 minus 1. So we just swapped our points. Let's say you picked the higher point first. So now I'm going to get -1 instead of 1. And you're like, oh no. But I'm also going to get -1 on the bottom. So surprise, surprise, we still get +1 as our slope. So it really doesn't matter which point you choose. They will give you the same answer as long as you get the correct y2 and y1 and x2 and x1. As long as they're consistent, it doesn't matter which points you pick. So this is a basic explanation of slope, how it's calculated. And then we will move along. So the next thing I want to do is talk about that y-intercept thing. So we now know what the slope of a line is, right? It's how the line moves. It's the rate of change of the line. But we don't know what the y-intercept thing is. So let's take a zoom in on our little graph we made before, right? So our graph, we see that we have, this is the y-axis, right? We have the y here and the x here. So the y-axis goes up and down, just like the length of y. That's how I always remember it, right? The long y goes up and down. And the y-intercept, what we refer to as the y-intercept, is the point where the line crosses the y-axis. So what that means is, let me just move this. What that means, right, is not only will it be on the y-axis, that means that the x-coordinate is always 0, right? Because it's always on the y-axis, which is 0 in the x, right here, right? So as we can see in this line, we cross the y-axis right actually at the point we were looking at before, at 0, 2. So that means that our y-intercept in this case was actually this point itself, 0, 2. So our y-intercept is 2, or 0, 2, if you want to write the whole coordinate point. So let's revisit that original equation we were talking about before, that y equals mx plus b, because now we have all of the proper information to complete this whole equation. Forgive me, I'm getting used to the new whiteboard. So y will always stay as y, right? We will eventually plug in values or something, but y and x always stay in the equation as y and x. We don't have to designate any numbers for them. Now m, we said m is the slope. And we found the slope, which was the rise over run, which gave us up 1 over 1, which was just simply 1 over 1, so 1. And then our x stays as x, right? We don't put anything in for x. And then plus b, we said b is our y-intercept, which is where we cross the y-axis at 0 on the x. And we said that that was this point 0, 2. So we simply add a plus 2 because 2 is where we cross the y-axis. Okay, great. So now we've filled out the whole equation for this line. So this is a really simple explanation of how you find the equation of a linear graph and how you can calculate slope and find your y-intercept. Now, there's a few other things we can do with linear equations, which I will link in separate videos, including finding the equation of a line based off of points it crosses through, which will have to do with point slope equation, as well as maybe some examples we can do with negative slopes and a little bit more complex slopes. Yeah, so that's all for this video. Really quick introduction to linear equations and what the variables mean inside of them. So watch the following videos if you want to see more examples or learn more about point slope equation. Thanks.